Out in the vastness of space, countless celestial objects hurtle through the cosmos. Some are small, like grains of sand, others are enormous, like planets, and then there are asteroids, rocky remnants from the early solar system. These space rocks come in various shapes and sizes, and their paths sometimes intersect with Earth's orbit. One such asteroid, dubbed 2024 YR4, has recently caught the attention of astronomers. This space rock, estimated to be between 130 and 300 feet wide, is not exactly a planet killer, but its potential impact could still have significant consequences on a regional scale. Imagine the energy released by thousands of Hiroshima bombs detonating simultaneously. That's the kind of destructive power we're talking about. The discovery of 2024 YR4 is not unusual. Astronomers constantly scan the skies looking for near-Earth objects that might pose a threat to our planet. What makes this particular asteroid noteworthy is its initial threat assessment. When first detected, calculations suggested a 3.1% chance of 2024 YR4 colliding with Earth on December 22, 2032. A 3.1% chance of impact might not sound like much. After all, you're more likely to win the lottery than experience an asteroid collision. However, in astronomy, even a tiny probability can have enormous implications. Imagine playing Russian roulette with 32 chambers and one bullet. Those are odds nobody wants to gamble with. Astronomers use the Torino scale to assess near-Earth objects like 2024 YR4. This scale, from 0 to 10, communicates impact likelihood and potential damage. Level 0 means no chance of collision, while level 10 means certain global catastrophe. 2024 YR4's 3.1% chance placed it at level 3 on the Torino scale. This yellow designation signifies a close encounter that merits careful monitoring. The Torino scale isn't just about numbers and probabilities, it's about effective communication. It's about conveying complex scientific data to the public in a clear and understandable way. Think of it as a traffic light for asteroid impacts. Green means go about your day, yellow means proceed with caution, and red means stop everything and take cover. Each level on the Torino scale corresponds to a specific range of impact probabilities and potential consequences. Level 1, for example, represents a routine discovery that poses no unusual level of danger. Level 2 indicates a close approach that might warrant concern, but is unlikely to result in an impact. Levels 3 and 4, on the other hand, signify close encounters that require further observation and might pose a localized threat. The higher levels of the Torino scale, ranging from 5 to 10, are reserved for events with a significant chance of causing regional or global devastation. Thankfully, no asteroid has ever reached these upper levels, and astronomers are constantly working to ensure it stays that way. Section 4. Refining the trajectory. As astronomers tracked 2024 YR4, the predicted probability of impact began to decrease. This is common with newly discovered asteroids. Initial observations are often based on limited data, and as more information becomes available, the projected path can shift. Think of it like predicting where a flyball will land. At first, you might only have a vague idea, but as you watch the ball's trajectory, your prediction becomes more accurate. Similarly, with more observations, astronomers refined their calculations. The updated data revealed a much lower probability of impact. Section 5. The flyball analogy. The analogy of tracking a flyball perfectly illustrates why asteroid impact predictions can fluctuate, especially in the early stages of observation. Just like a baseball soaring through the air, an asteroid traveling through space is subject to various gravitational influences that can subtly alter its trajectory. The gravity of the Sun, for instance, exerts a constant pull on all objects in the solar system, including asteroids. But the gravitational tug of other planets, particularly those near Earth's orbit like Mars and Venus, can also nudge an asteroid's path, causing it to deviate from its expected course. The more data astronomers collect about an asteroid's position, velocity, and the gravitational forces acting upon it, the more accurate their predictions become. It's like adding more data points to the flyball analogy, allowing you to factor in wind speed, air pressure, and even the spin of the ball itself. With each new piece of information, the predicted landing spot becomes more precise. Section 6. A history of close calls. The story of 2024 YR4, with its initial high-risk assessment and subsequent downgrade, is not an isolated incident. Throughout history, there have been numerous cases of asteroids briefly capturing the world's attention as potential threats, only to be later reclassified as harmless after further observation. One such case involved the asteroid Apophis, which in 2004 briefly reached level 4 on the Torino scale, the highest level ever assigned to an asteroid. Initial calculations suggested a 2.7% chance of Apophis colliding with Earth in 2029, sparking widespread media coverage and public concern. However, as with 2024 YR4, further observations of Apophis allowed astronomers to refine their calculations and rule out the possibility of an impact in 2029. The asteroid is still expected to make a close approach to Earth, coming within about 19,800 miles of our planet's surface, but it will pass by safely. Section 7. Keeping watch. The cases of 2024 YR4 and Apophis highlight the importance of continuous observation and refined calculations in assessing the risk posed by near-Earth objects. While initial observations might suggest a potential threat, further data can quickly change the picture, often for the better. The field of asteroid detection and tracking is constantly evolving, with new telescopes and technologies coming online all the time. These advancements allow astronomers to spot smaller objects at greater distances, giving us more time to react if a real threat is ever detected. The goal is not just to identify potential threats, but also to develop strategies for mitigating them. Scientists are exploring various options for deflecting or disrupting asteroids that might pose a danger to Earth, ranging from kinetic impactors to gravity tractors. In the vast cosmic arena, where celestial objects move at unimaginable speeds, knowledge is our greatest defense. By continuing to study asteroids, track their movements, and develop technologies to protect our planet, we can ensure that the story of 2024 YR4 remains a tale of scientific discovery and not a harbinger of cosmic disaster.